Well, welcome back. And tonight our goal is to wrap up our study of statistics, and it's going to get real fast as we dive into a lot of real life examples tonight. And as our title suggests, we're focused on evaluating reports based on data from an experiment. Now, this idea of an experiment is really big. Because we use experiments in everyday life to determine cause and effect relationships, cause and effect. Now, it's important to learn how to evaluate these reports about experiments to determine the validity of the conclusions made from the experiment. Do you really buy it? Do they have a large enough sample size? Did they do a good enough job of randomizing the samples? How did they break the groups up? How did they determine who's in the control group versus who's in the experimental group, and so on and so on. So we're going to give you a few guidelines first, and we're going to dive into a real-life experiment. So a few guidelines to go by, and first and foremost, a cause and effect relationship. Cause and effect relationship can only be shown by a well-designed experiment. Now, what we're trying to stress here is that it's only an experiment that can determine cause and effect. A cause and effect cannot be proven by an observation, or, as we studied earlier, a specific type of observation is known as a survey. So no matter how great or how well performed your survey or observation is, at the end of the day, you cannot conclude a cause and effect relationship, and that's really important when you're trying to prove something. Number two, randomly assigning the subjects, and we can't stress this enough, randomly assigning the subjects to treatment groups. Again, the treatment might be a fertilizer that you give your tomatoes, or it might be a new medicine that you're trying to test out. Evens out the effects of extraneous variables to create comparable treatment groups. Because at the end of the day, we want to be able to compare apples to apples. And when we can do that, then we can definitively draw some great conclusions. All right, number three. Now, we're going to go over some new lingo. Get this rascal back here. First of all, a control group, which is another name for a placebo group. Okay, and now they don't know they're getting the placebo or the fake medicine or the fake fertilizer. The two pills are designed to look, taste, smell, and everything be the same. So we have a control group, or we have what's called the comparison group. Man, I guess I did not make my blanks long enough tonight. Or a standard treatment. So this is the group that's getting the real drug or the real fertilizer, is sometimes included in an experiment so that you can evaluate the effect of the treatment. Is it statistically significant? Did the fertilizer actually make the tomatoes grow bigger, or could we leave it up to chance that they were just a little bit bigger by chance? Maybe they got more sunlight or something out of our control. And our last general guideline, the number of subjects in each treatment group, also known as the sample size, should be large enough. And general guideline, as long as they're randomly selected, we're thinking the bigger the better. Large enough for the random assignment to the experimental groups to create groups with comparable variability between the subjects. As we kind of alluded to on the opening slide here tonight, we're going to dive into an article from the Journal of Strength and Conditioning Research to give you a real live example of what an experiment looks like in the different control groups and so forth. And I read a lot of research articles in the field of medicine, and overall I found them rather depressing. So I went in search of some kind of other topic, and I came up with one that I think might be slightly interesting here. We're going to study the impact of back squats and leg press exercises on maximal strength, and here's the one I'm interested in, speed strength parameters. Okay, and this may be easier for you to just hit the pause button and read it to yourself. But then I'm going to run through and read it out loud. If you have the ability to print this off and tape it into your notebook, that also might be a great point of reference, and just to be able to highlight certain things and refer back to them tomorrow in class. Here we go. The impact of back squat and leg press exercises on maximal strength and speed strength parameters. strength training induced increases in speed strength seem indisputable. For trainers and athletes, the most efficient exercise selection in the phase of preparation is of interest. So basically what they're saying in here is we already know that if you get stronger, you're going to run faster. It's going to increase your speed. Now the question is, how do we train our athletes the most efficiently? How can we do it in the quickest amount of time and do it in the healthiest way possible? Therefore, this study determined how the selection of training exercise influences the development of speed strength and maximal strength during an 8-week training intervention. 78 students participated in the study. 39 were in the training group, or the experimental group, and then the other 39 were as controls, and that's like our placebo group right there for comparison purposes. Both groups were then subdivided into 2 subgroups. The first training group, called our squat training group, abbreviated SQ, completed an 8-week strength training protocol using the parallel squat. The second training group, we'll call them the leg press training group, abbreviated LP, used the same training protocol using the leg press to a 45-degree angle. The control group was then subdivided into 2 subgroups as controls for the squat and the leg press group. Now this next sentence is a little goofy. It's a little more high-tech than what we're ready for, but we'll give it to you anyway. A 2-factorial analysis of variance were performed using a repeated measures model for all group comparisons and comparisons between pre-test and post-test results. Now here's the kicker. Here's the part where the next 2 or 3 sentences are the most important. The squat exhibited a statistically significant increase in jump performance in squat jumps. In fact, they had a 12.4% jump, that increase in performance. That's outstanding. And also something called counter movement jumps, where they saw another 12% increase. Again, that's outstanding, especially an 8-week program. Whereas the changes in the leg press did not reach statistical significance and amounted to improvements in the squat jump of just 3.5% and in the counter movement jumps of just 0.5%. The differences between the groups were statistically significant. And what we're trying to say right there is the squat was a much more efficient training model than the leg presses. There are also indications that the squat exercise is more effective to increase drop jump performance. Therefore, the squat exercises increase the performance in squat jump and counter movement jumps and reactive strength index more effectively compared with the leg press in a short-term intervention, short-term being an 8-week program. Consequently, if strength training aims at improving jump performance, the squat should be preferred because of the better transfer effects. So what I'm going to try to do is I fire a bunch of questions at you. I'm going to try to do a little cut and paste of what part of the article I think it helps us answer the question. First question, how many treatment groups were there? Well, right here we said the 78 students were broken into, 39 were in the training group. That's our treatment group right there. And then the other 39 were for controls or placebo. Now that training group we had was then subdivided into 2 subgroups. So for me, I'm going to say that there were 2 treatment groups, and we'll say in this case one of them was for squats and one of them was for leg presses. Okay. Secondly, as far as what treatments are being compared here, it's kind of like a 3-way comparison. In other words, we're comparing our squats versus our leg presses versus our control groups. And we're basically saying we're looking for the most efficient way to improve our speed and our jumping ability. Now, is there a placebo group? And I would say yes, that is our control group. Now, they weren't really specific here in the abstract part of the article. I'm sure they'd be more specific in the full article as to what these 39 people in the control group are doing, but basically they're probably not involved in any workout at the gym. They're probably not going to the gym. Usually in the control group you give them the placebo. They think they're taking the numerical drug when in reality they're really not. In this case, you can't give them like a fake squat or a fake leg press. You just probably have them doing something outside of the gym and then retesting them 8 weeks later. Okay, how many subjects were in each treatment group? And that's a real easy one. There was 39 in the experimental group, and there was another 39 in the control group or the placebo group. And then those groups were subdivided and I'm guessing, they didn't specify, but I'm guessing like 20 and 19, for squat and leg press. And then the same thing here, they were subdivided into a 20 and a 19 for comparison purposes to see if there was any statistically significant improvements. Do you think that the number of subjects in each treatment is enough? And I had to think about this one a little bit, but in this case, and I don't think it's a slam dunk, but I did say yes. I think, 39 committed training athletes is going to give us a chance to see some statistical significance. In a perfect world, we'd love to see more. It'd be great if there was 200 athletes or 1,000 athletes. But I think, considering, it's they got to commit to an 8-week program, and it didn't sound like they were paying them anything. So I think 39 is a pretty good number. And whereas I don't think, maybe if you had 4 or 5, maybe you could cough it up to chance and some rare things. But if 39 athletes all show improvements in a certain category, then you can say that with confidence that it really did work. Here's another question we always want to ask ourselves is what method was used to assign the subjects to the different treatment groups? And unfortunately, I don't think the abstract, I'm going to say it didn't really say. Again, if we'd have read the full article instead of just the abstract, maybe they would have got into more depth there. But we do want to, before we really put a lot of stock in this article, we would want to verify that there was some randomness involved. Because when it comes to athletes training, every athlete, they get different amounts of sleep, they have different diets, some are more stricter and do a better job of getting a healthy diet, while others are a little more casual about it, and you just hope that those things level out. When you look at the 39 in the experimental group versus the 39 in the control group, you hope that you've got an equal amount of healthy eaters in this group as you do in this group, and you hope that you get they average about the same amount of sleep in this group as they do that group, and that all these other variables play out. But anyway, that's all I've got for you tonight. We're going to look at a couple of other articles tomorrow, some other abstracts, and try to ask similar questions. And we're going to see some really good ones, and we're going to see some not so good ones. And I'll give you a heads up right now. Watch out for observations. Remember, if it's not an experiment, we cannot draw any cause and effect conclusions. So there's my heads up tip for tomorrow. All right, have a great night, and I'll catch you tomorrow.